Okay, now let's try to use this formula to solve this integral. So when we do the integration by parts, the key or the first step is to determine which part of this expression do we let be ux and which part do we let be dv. So it is similar to when we use u substitution, right? The first step is to determine which expression do we let be u, right? Okay. So the idea is, if you look at the right hand side, and you will see, because later on you have to figure out the du, right? To figure out the du means you're gonna differentiate the ux. You're gonna differentiate the ux you determine here, and over here you're gonna integrate the vx, right? You're gonna integrate the dv to find the vx. So therefore, the ux it must be something which is easy to differentiate. It's something easy to differentiate, and the dv is going to be something that is easy to integrate. So we can use this as a guideline when we are searching for ux and dv. Okay, now let's take a look at this problem. So we have x ax dx. It seems that both of them are easy to integrate and differentiate, right? So let's consider the two different possibilities, and then see which will give us a nice integral. Because once you choose u and v, and once you write your result into this term, so the only difficulty is here, right? So if you can integrate this expression, then you'll be done, right? Okay, so let me try. If I let ux be x, and if ux equals x, that means the rest of this expression gonna be dv. So this is one composition, right? Or if I let ux be ex, that means the rest gonna be x times dx. So dv gonna be x times dx. Okay. Now let's compare these two ways to see which way will work. Since on the right hand side, I need to figure out du and vx. So if my ux is x, now the du is gonna be the derivative of the x. So let me take the derivative of ux. So I get 1. So then du equals x, right? du equals x. And let me see what is a v. To find a v, I need to integrate. So I need to integrate. That means I'm gonna integrate the ex dx, so I can find a v. Well, this integral is easy to solve, right? Which is ex. So the vx equals ex. So this equals, so Vx equals Ex. So therefore, the result when we integrate x times ex dx, the result equals ux times vx minus the integral of vx times du. And because we determined that ux to be x, so this is x, and over here we figure out the vx equals ex, and minus here, so the vx is ex and du is a dx. So then this integral give us the answer is ex. So therefore we found the answer. When we integrate this function, the result is x times e to the x minus e to the x plus a constant c. Alright, now let's see what will happen if we choose this way. Okay, so if we let ux be ex, so that means du over x is e to the x, so that means du is gonna be ex times dx, right? Okay, and if dv is x times dx, so vx, to find vx, we're gonna integrate dv. This means we're gonna integrate x times dx, and this will give us x squared over 2. So vx is x squared over 2, and du is ex dx. So according to the formula, so the first term is ux times vx, which is ex, right, times x squared over 2, and minus the second term is the integral of vx times du, which is x squared over 2 times du. Now, once we get here, you will see we have a problem, and the problem is in this result, this integral it seems more difficult than the integral we had at the beginning, right? So that means this way it doesn't work, because it will generate a much more difficult integral. So the right way to choose u and dv is like this.